Hello student, most welcome to Dr. Acharya Academy. Today I am going to discuss LCAO theory. That means formation of molecular orbitals, linear combination of atomic orbitals. In short, it is called LCAO theory. Today's class number is 085. From the wave mechanics theory, we know that atomic orbitals is expressed in respect of wave functions, and these wave functions represent the amplitude of the electron waves. And these electron waves is obtained from the solution of Schrödinger wave equation. But it cannot be solved for the system which have more than one electron, like molecular orbital. Molecular orbital which contains more than one electrons, and for this it is very difficult to obtain the solution of wave functions for the molecules directly from the solution of Schrödinger wave equation. To overcome this problem, the new concept adopted, which is called the linear combination of atomic orbitals to form molecular orbitals. Let us apply this method for the homonuclear diatomic hydrogen molecule. Consider this is the two hydrogen atoms, and both have 1s orbitals with single electron. And if it is hydrogen atom denoted by A, then its wave function is psi A, and this is hydrogen atom, consider B, then its wave function is psi B. So mathematically, the formation of molecular orbitals, which is described by this LCAO method, it can take place by the addition, is the addition of wave functions of these two hydrogen atoms, or the subtraction of the wave functions of these two hydrogen atoms, A and B. That means the psi molecular orbital is equal to psi A plus minus psi B. So when it is addition of the wave functions of these hydrogen atoms, then it is denoted by sigma. And when you subtract the wave function from one to another, here you consider psi A minus psi B, and then this molecular orbital is denoted by sigma star. So sigma is the bonding, denoted by bonding, and sigma star denoted by anti-bonding. So the molecular orbital sigma formed by the addition of the atomic orbitals is called the bonding molecular orbital, and this sigma star molecular orbitals formed by the subtraction of atomic orbital is called anti-bonding molecular orbital. So this is the bonding orbitals and this is the anti-bonding orbitals. Now qualitatively, qualitatively, the formation of molecular orbital can be understood in terms of the constructive or destructive interference of the electron waves of the combining atoms. So we'll understand this. And in right side figure, you can see the two electron waves of the bonding atoms reinforce each other due to the constructive interference. In this case, you see the wave functions or electron waves of two individual atoms when you form the molecule. Then when it is the addition of these wave functions, then it is called the constructive interference, and it will form the bonding orbitals. While the formation of the antibonding molecular orbitals, these are antibonding molecular orbitals, the electrons waves, these two electron waves from each atoms to destructive. That's why you can see subtract. Subtract means it is destructive in nature, and this wave is maintaining the distance. That means repelling each other in this case to form the antibonding orbitals. So what happens? The electron density in the bonding molecular orbitals is the bonding orbital is located between the nucleus of the bonded atom. Locate in between this electron density here, and because of which the repulsion between the nucleus is very less. So repulsion between this nucleus is very less. And in case of antibonding molecular orbitals, most of the electron density is located away from the base. This is a space. So it is away in right side, away from the base, and left side it is away from the base between the nuclei. This is the nucleus of these participating two atoms to form the molecules, and these electrons are electron density is located away. Right side for right side atoms, the electrons located for the right side from the nucleus, and for the left side atom, this is the nucleus, and electron density is located away in left side from the nucleus. There is a nodal plane. Which is the nodal plane? Nodal plane where the electron density is 0. It is between the nucleus, and hence the repulsion between the nucleus is high. So here the electron density is 0, and that is the reason for the antibonding molecular orbitals, the repulsion between these two nucleus is very high. You see here no electron is there. That's why this nucleus for one atom, the another nucleus of the another atom, its repulsion is very high. So electron placed in a bonding molecular orbital, these are bonding molecular orbitals. Here electron placed in a bonding molecular orbital tend to hold the nucleus together because it is in between, that electron cloud is in between. So it will act as bonding to the two nucleus to each other, and in that way, by making the bonding orbitals, the molecule is stabilized. So a bonding molecular orbitals always possess lower energy. We know it is the stabilized, so it possesses the lower energy. You see this y-axis in the left, it represents the energy upward. So these bonding orbitals is down, that means it is less, bonding orbitals has less energy than the participating two atoms. But the electron placed in the antibonding molecular orbitals, this electron placed in the antibonding orbitals, it destabilizes the molecule. And for the antibonding orbitals, this molecule's energy always higher than the participating atoms. And why? This is because the mutual repulsion of the electrons in these orbitals is more than the attraction between the electrons and nucleus. This mutual repulsion between the electrons is more than the attraction between the nucleus and electrons. And it causes the increase in energy of the molecule with antibonding orbitals than the participating atoms. It may be noted that the energy of the antibonding orbital is raised above the energy of the parent atomic orbitals, what I already said now, that have combined, and the energy of the bonding orbitals has been lowered than the parent orbitals. So this is the parent orbitals. So bonding orbitals has lower energy than this, and antibonding orbitals energy is more than the energy of the parent orbitals. This is the parent orbitals. So the total energy of the two molecular orbitals, total energy of these two molecular orbitals, one is bonding orbitals and one is non-bonding orbitals, the total energy of these remains same with the energy of the original atomic orbitals. That means the parent orbitals total energy is same of the sum of the energy of the antibonding orbitals and the bonding orbitals. I hope that you understand this LCAO method to explain the molecular orbitals, how this is created from the atomic orbitals, and two types of molecular orbitals is there, bonding orbitals and antibonding orbitals. Thank you so much for watching this class.